Okay, for next question, these are four long answer questions in this section, and each section is of 5 marks each. So, this is the first part of question number 32, and A is a square matrix of order 3. We have to find A inverse and hence solve the following system of equations. So, first of all, let's find out A inverse. And to find out A inverse, so we know that formula for A inverse is adjoint of A by determinant of A, and we have to check where find out determinant of A and adjoint of A. Let's find out determinant of A. So I'm going to expand this long row, second row, because we have 1 0 in this. So this is plus and negative. So the first one is negative 2, and removing the row and the column for this, we are left with 2, negative 3, 2, and 0. Second one, we need not have to take 0, just go to the last one. So this is positive, and negative. So this is negative of negative 3. And removing the row and the column for negative 3, we are left with 1, 2, 1, 2. Okay, so determinant of A is equal to negative 2. 2 into 0 is 0. Minus 2 into negative 3 is negative 6. This is plus 3. 1 into 2 is 2 minus 2, which is 0. Okay. Okay. Now, determinant of A is equal to this becomes 6. This term is 0. So this is negative 12. So negative 12, which is not equal to 0, that means A inverse exists. Okay, now let's find the adjoint of A. To find the adjoint of A, so I have got a determinant of A which is negative 12. So let me just simply write it here. I'm going to erase this. So determinant of A is negative 12, and I'm going to now find adjoint of A, for which let's find the cofactors A11, A12, and A13. And this is where I'm going to write the adjoint of A. So A11, A12, and A13. And let's assign the sign to them first. So 1 plus 1, adding the row and the column, 1 plus 1 is 2, which is even. So let's put the positive sign. For odd, we put the negative sign, and it's even. Now remove the respective row and the column for element in the first row and first column. So if I remove this, the determinant is 0, negative 3, 2, and 0, which gives me this is 0 and negative 6. The second one is removing the row and the column for second one. So we are left with 2, negative 3, 1, and 0. So this is equal to negative 2 into 0 is 0, and negative of negative 3, 0 minus 3, which gives me negative 3. Okay, for 1, 3, it's removing the row and the column for this one, it's 2, 0, 1. So 2, 0, 1, 2, which gives me 4 minus 0, which is equal to 4. So we have got the cofactors for the first row, and we are going to write them in the column here. So this is negative 6, negative 3, and 4, because adjoint is the transpose of the cofactor matrix. So negative 6, 6, negative 3, and 4. And actually, this should be 6, because 0 into 0 is 0 minus of minus 6, which gives me 6. So this is 6. Okay. Similarly, we can get the cofactors of the second row, and cofactors of the second row are for 2, 1, 2, 2, and 2, 3. So 2 plus 1 is 3, which is also negative. This is positive, and this is equal to negative. Okay, 2, 1. So this is element in the second row, and first column. So this is 2, -3, 2, and 0. So removing the second row and the second column. So removing the second row and the second column, it's if you remove the element in the second row and second column, it's 1, -3, 1, and 0. 1, -3, 1, and 0. And this is if you remove the row and the column for the third one, suppose 1, this is 1, 2, 1. So 1, 2. Now this is equal to -2 into 0 is 0, negative of -6, which is equal to -6. This is equal to 0 minus of -3, which is equal to 3. And this is equal to 2 minus 2 negative, which is equal to 0. So this is -6, 3, and 0. Okay, now let's find out the cofactors for the third row. Okay, so third row means 3, 1, 3, 2, and 3, 3. So 3, 1, it's plus, it's negative, and it's plus. Let's remove the row and the column here. So if you remove the row and the column for this, 2, -3, 0, 3. This is 2, -3, 0, and -3. For the 3, 2, for 3, 2, it's 1, -3, 2, and -3. Okay, for 3, 3. If you remove the row and the column for this, we are left with 1, 2, 2, 0. 1, 2, 2, 0. Okay, now it's -6, negative of this is -6 because 0 into 3 is 0. This is negative of -3 minus of -6, which gives me negative -3 plus 6, which is equal to -3. And this is -4. So -6, -6, -3, and -4. This is the adjoint. So we have got the adjoint of A 6, -6, -6, -3, 3, -3, 4, 0, -4. And let's find out now the A inverse. Okay, now we have got determinant of A, we have got adjoint of A, and we have to find A inverse, which is adjoint of A matrix divided by the determinant, which is -12. So this is -1 by 12, and 6, -6, -6, -3, 3, and -3, 4, 0, and -4. This is A inverse. Now using this, we have to solve this system of equations, and we know that this system of equations, we can write it in the matrix form as Ax is equal to B, where x, which gives me x is equal to A inverse B. Now, has the variables, X matrix has the variables X, Y, and Z, and we have the A inverse, which is -1 by 12, and which should be 6 minus 6 minus 6. This is -3, 3, -3, 4, 0, and -4. Okay, and we have to multiply this with the A matrix, sorry, B matrix. B is a matrix that has the constants which are 1, 2, and 3. So this is 1, 2, and 3. Okay, so let's find the product of this, which is 6, -6. Okay, we are ready to find out the product. So how do we find out the product? So let's keep it out. So we have to find the sum of the product of the respective elements of the row and the column. So 6 into first element is 6 into 1, and then -6 into 1 and -6 into 2, which is negative 12. Once again, negative 12 is not there. It's negative 6 into 3, which is negative 18. Okay. Then take the second row. This is negative 3 plus 6, negative 6. Then 4 and 0 and negative 12, which gives me this is equal to negative 1 by 12. So 6 minus 12 is negative 6 minus 18 is negative 24. This gets cancelled. This is negative 3. 4 minus 12 is negative 8. Okay, so let's divide this with 12. Negative 1 by 12, which gives me 2. And this gives me 12 to the, and this is 1 by 4. The second element is 1 by 4, and the third element is 2. It's 4 to the 8 and 4 3 the 12. So these are the values of x, y, and z. So x is equal to 2 and y is equal to 1 by 2. Y should be equal to 1 by 2. Okay, this is, let me check it. This is minus 3 and 3 to the is 6 and minus 3 into 3 is 9. This should be actually 9. Minus 9. This is minus 9. So now the 6 remains here and we get minus 3 plus 6 is 3 minus 9 is negative 6, which gives me 1 by 2. So this is 1 by 2. So x is 2, y is 1 by 2, and z is equal to 2 by 3. These are the values of x, y, and z.